an event A is given by probability of event is equals to number of event divided by number of sample space, or simply it is probability of event equal to its number of event, it's m divided by number of sample space. By the way, sample space it is the total possible outcomes under the experiment. For example, if you toss or roll a die, the total possible outcomes or sample space will be this 1, 2, 3, 4, 5, 6. This is the total possible outcomes under experiment. We call it sample space, and the subset of this sample space we call it event. For example, number getting odd number odd getting odd will be subset of the sample space. So we have one event. So event getting odd number will have 1, 3, 5. This is it. If you are asked what is the probability of getting odd number when you roll a die, probability of the event is equal to this number of events divided by number of sample space. Here the event is getting number odd, so we have 3 possible events here. Therefore number of events is 3 divided by sample space is 6. 3 over 6 will be the probability of getting odd number when you roll a die. So probability of an event is given by number of event over number of sample space. So let's see example. A box contains 4 red and 5 black balls. If one ball is drawn at random, what is the probability of getting red ball? So simply here, probability of the event is given by number of event divided by number of sample space. The event here is getting red ball. How many red balls do you have? 4. We can count easily here. It's given 4 divided by the total number of balls or sample space is 4 plus 5 is 9. So the probability will be this 4 over 9. But sometimes we face some complex thing to count. In that case, we need to have some counting technique. So let's see counting techniques or principle of counting. To evaluate probability, we count. So we need to have a counting principle for complex cases. So the first counting principle is multiplication principle. If an event E1 occurs in m different ways and another event E2 occur in n different ways, then both events together occur simultaneously in m times n different ways. By the way, you can extend this for more than 2 events. For example, if we have 3 events E1 that occurs in m different ways and another event 2 occurs in n different ways and another event 3 occurs in other different ways, then these 3 events simultaneously occurs in n times r different ways. Now let's see example for this example. Suppose that you have 3 coats, 8 shirts and 6 different trousers. In how many different ways can you dress? It says here. So here we have event 1, we have 3 coats, event 1, 3 different ways of wearing style for coat and 8 different wearing style for shirt and 6 different wearing style for trouser. So we do this simultaneously. So event 1, 3 ways. First, event 2, 8 ways, and event 3, 6 different ways. these events together occurs in simply 3 times 8 times 6 different ways. So E1, E2, and E3 simultaneously occurs in 3 times 8 times 6, which is equal to 144 different reading styles. Okay, now let's see the second principle of counting, addition principle. If an event E1 occurs in m different ways and another event E2 can occur in n different ways, then either of the events occur in n plus m. In this case, you add n plus m different ways. But this is true when the events are mutually exclusive. Mutually exclusive events are events that do not have intersection or common. So for mutually exclusive events, if event 1 occurs in m different ways and event 2 occurs in n different ways, so either of event 1 or event 2 occurs in m plus n different ways. Now example, a question paper has two parts. A question paper has two parts, where one part contains 6 questions and the other part contains 4 questions. If a student has to choose only one question from either part, in how many different ways can the student do it? Okay, here we have 2 events E1. For from part 1, he select one question. So in how many different ways can he select? In 6 different ways. Either he select the first question, second or third or fifth, fourth and sixth. Therefore, he has 6 different ways of selection for the first part. So event 1 has 6 different ways, and he can also choose second part. So from second part, since that's 4 questions, he has 4 different ways of selecting the question. So he cannot do the questions from part 1 and part 2. He will select either from part 1 or part 2, from event 1 or event 2. Event 1 here occurs in 6 different ways, and event 2 occurs in 4 different ways. So the number of different ways either doing from event 1 or event 2 is simply the sum of these numbers, 6 and 4. Therefore, event 1, 6 different ways, event 2, 4 different ways. So E1 or E2, event 1 or event 2 occurs in 6 plus 4 or in 10 different ways.